This is All Things Ansys, a podcast from the technical support staff at PADT, episode 118, all about Ansys HPC licensing. Greetings all, my name is Eric Miller, and I'm your host for these podcasts as well as one of PADT's three owners. I know that when we came back from our hiatus, we said we were going to do just one episode a month of All Things Ansys, and that's still the plan, but it turns out not only do people actually listen to this podcast, we listen to our listeners. We recently received a request from a regular listener to have an episode about Ansys's HPC licensing options. It turns out that it is a bit of a complex subject because Ansys has spent some time tweaking the various ways you can get access to more GPUs and cores that make sense for a wide variety of users. So, this is a short episode, mostly our discussion on that topic. Therefore, without further preamble or introduction, let's listen in on the discussion. I had with some key members of PADT's technical support team, all about Ansys HPC licensing.
So I want to welcome everybody for joining us today. We're going to have a discussion, which is the first time in a long time was prompted by an email from a listener to the podcast who, like many of us, myself included, can get a little overwhelmed by trying to get their head around how HPC, high-performance computing, licensing works in the Ansys product suite. So this is basically parallel and things like that for running on multiple cores or multiple GPUs across machines, all that stuff. Ansys has a licensing scheme for that makes it a value add for the users, but it can get a little complicated. So we've asked some of our experts here from our tech support team to join us and help me understand it, and hopefully by helping me understand it, it'll help you understand it. So I've got Alex, Daniel, Ahmed, and Ted. So Alex, why don't you introduce yourself and what you do here at PADT?
Sure. My name is Alex Moody. I'm an application engineer at PADT in the electronics area, so high frequency, high speed electronics, tools like HPC and SI Wave. And I've been at PADT for about a year and a half now, I would say.
Fantastic. Daniel.
Hi, Daniel Chaparro. I'm an application engineer for the Fluids part of the business. So CFD with Fluent primarily. Been with PADT for about 3 years, and background is primarily in aerospace.
Fantastic. Ahmed.
Yeah, so I handle licensing, installations, HPC, RSM, basically making sure that the software runs as it should. I've been with PADT almost 9 years now.
Great. Yeah, if you're a PADT customer and you call about any of these kind of IT issues, including licensing, Ahmed's the one that helps you out. And then Ted, let us share what you guys do here, what you do here.
Okay, sure. So I'm the director of our simulation support team here at PADT. So Ahmed, Daniel, and Alex are all members of the team. Long time at PADT, long time user of Ansys. So haven't used the tools from an HPC standpoint myself in quite a while, but happy to contribute where I can on our call today.
Cool. Well, I appreciate it. So everybody kind of jump in as we go through this. I think the most important thing to start with is, does anybody want to kind of explain what HPC is, what parallel solving is?
All right, I'll break the silence.
There we go. Thank you. You first.
Initially, way back when, basically when CPUs were introduced, they were single thread, where you can only run a single instruction at a time. If you think about it, in simple terms, it's like one of those flashing lights when you're trying to get on the highway. Mm-hmm. So every green light, you get one car going through. With development of CPU technologies, you started getting more and more lanes where the CPU now behaves like a 6-lane, 10-lane, 12-lane highway. Mm-hmm. The most recent CPUs, you can go up to 64 processes or 64 instructions can execute in parallel.
On one chip, right?
On a single chip, yeah. And then on top of that, they added virtualized chips, so you can double that number. So with this many lanes open, software developers, especially people who are compute heavy, started developing software that utilizes this multi-lane highway to run instructions. And what this reflected directly on the results is you get faster output. And from there, the concept of high performance computing or parallel computing came out. So you have parallel processors, and then you connect multiple machines together, and then you have a parallel cluster or a high performance cluster. And in some environments, you have thousands or tens of thousands of these machines running in parallel, providing millions of highway lanes to execute instructions.
Right, and this is not just CFD, right? It's almost all of the Ansys products have some parallel capability. Is that a valid statement these days?
That is correct. The majority of Ansys, probably all of Ansys products have an HPC element to them. It's just, does the math work in parallel? Can you break down the math into, separate chunks that can process side by side?
Like you said with the cars, right? Can I load up 6 cars and drive them side by side rather than 6 in a row or one full of everything? Yeah. So we won't get too much. That's all I want to kind of cover from the HPC standpoint, and we can certainly come back and talk about that a little bit later. But it's really the licensing. So my understanding is that Ansys has multiple ways to access, and the most important one is when you have a license of an Ansys product, you get how many cores with that license?
So by default, the solvers provide 4 cores. So you can solve on four separate threads or on 4 separate cores at the same time.
So my mechanical license or my CFD license, and is that true for HFSS as well? I don't.
That's also true for HFSS, correct.
Right. So I basically can, and most desktops now, right, have 6 to 8 cores built in or more. So that's great to know. So we're starting there. I'm old enough to remember when it was 2. So that's good that we get 4 included. I won't say it's free, but it's included in that base license. And then so I can buy individual HPC tasks. Is that correct?
That is true.
Okay. And those are just called, what do they call those? Just HPC license?
Ansys HPC.
Ansys HPC. So as an example, if I'm running Ansys Mechanical and I want to use 10 cores, I get 4 with my mechanical license, and then I need to consume 6 HPCs to get to 10, correct?
That's correct.
We probably need to whiteboard this to make sure we get it right. Okay.
So now, where it gets confusing is there's also something called HPC pack.
Right. Please explain that.
Okay. So in addition to individual Ansys HPC licenses, which can come one at a time or can be bundled in what's called work group. So customers can get a work group of, say, 32 or 64 Ansys HPC licenses. There are also Ansys HPC packs. And so one pack enables solving on an additional 8 cores.
Okay.
So the difference is a pack has to be consumed all at once. But 2 packs get you more than 8 times 2 additional cores. 2 packs enable 32 additional cores. And so 3 packs, I think, gets you to 128. Correct me if I'm wrong, guys.
64. It's doubled. Yeah.
No, 3 packs is 128.
Really?
128. Yeah. So 3 packs gets you to 128.
Okay.
It's a factor of 4. Yep.
But the difference with a pack is that, the way I try to explain it is it's like having, you go to the store and you can get, a 6-pack of beer or soda or water, whatever it is. And so for the individual Ansys HPC, that's like having a bottle at a time. So
okay.
you might have a work group bottle or work group pack of bottles that gives you 32 individual bottles, but you don't have to use all those at once. You can consume 2 at a time. You can consume 6 at a time, but you have 32 individual bottles. Whereas the HPC pack, those come in basically a sealed unit of 8, and you have to consume all of them at once. So one user is going to tie up all 8 of those. So even if there's only 6 additional cores available, all 8 of that HPC pack are going to be consumed and unavailable for anyone else to use. So it's just a different mechanism for how additional cores are enabled, and there's a different pricing structure. So as you might imagine, an individual Ansys HPC license is going to cost less than an HPC pack, but it really depends on how many cores you're planning on solving on. So if you have lots of cores, getting a few Ansys HPC pack licenses may be more cost effective than having the workgroup bundle of the individual Ansys HPC licenses. So with HPC packs, let's say you have 3 Ansys HPC packs available. So one user could consume all 3, and that would enable solving on additional 128 cores. Or you could have one user consume 1 pack that gives that user an additional 8 cores, and another user could check out the other 2 HPC packs, and that would give them access to 32 additional cores. Or you could have 3 users each checking out 1 HPC pack, enabling an additional 8 cores for each. So it really just depends on the use case and who needs which HPC resources as far as which model is better. But Ansys gives you options for how to purchase and utilize additional HPC cores. So hopefully that explains it.
Yeah.
You guys correct me if I'm missing something.
Oh, that's great.
So let me make sure I understand it, because I'm starting to get my head around it. So, and I like your analogy of I can buy soda bottles by themselves, which is just the basic HPC license. I can buy work groups, which is kind of a volume discount, but I can open the box and take the bottles out and drink them one at a time.
Right. Whereas
or I
with
can
the
buy
packs,
a pack.
You gotta drink all of them at the same time. So hopefully it's
box
water.
Wine.
Right. Hopefully it's water and not something that's going to make you sick or totally inebriated.
Yeah, exactly. Yeah. So I think that's a good way to look at it is if I buy the pack, I got to use them all at the same time. I can't take the bottles out individually, but there's a cost advantage to that. And
just to get away from that analogy, so the license, it's not a one and done. I mean, you check it out, you use it.
Good point.
And then it goes back in, and then the next person can check that out again. It's not like the drink where you're consuming it and it's gone. It's like I don't want to take the analogy further, but you're using it and putting it back. So
it's really good wine, and I'm just looking at the label and admiring it. Then I put it back. Yes. Okay.
Yeah, that works.
So I like the way of thinking it that way, and of course you have to talk to whoever you're buying your Ansys from on the pricing. But the basic idea is that if you buy 2,000 cores and you buy them individually as licenses, those single bottles, that's a lot more expensive than buying let's say 2,052. I think if you buy 5 packs, you get 2,052 cores. That's going to be much cheaper than buying with work groups or individual licenses.
And so within your application, and I think we're focusing on the flagship products here, which are Mechanical, Fluent, and probably HFSS or Maxwell. So within those tools, you're specifying how many cores you want to solve on. And I know for the electronics tools, you have to specify which of these 2 types of licenses that you are going to use, and most people have one or the other, but you still need to tell the tool which one you're going to use. And maybe Alex, you can explain that a little bit more.
Yeah, by default, it's set to pool, which is workgroup HPC. And if you have workgroup HPC, that's great. You don't have to change anything really. But if you have the HPC pack, you would have to go to that drop-down menu and select pack.
Okay.
Otherwise, you will get a licensing error. That's a pretty frequent problem where people install a new version of HPSS or Maxwell or electronics desktop in general, and they run a new simulation and forget to go check, did they switch it to pool or pack, and that error can arise.
So that's a really important takeaway. If you're listening and you're going to use this, remember to do that, because I can see that you got your model all set up, you're ready to kick off all these cores, and oops, that's good to know. It's good to know. So one question I had, we've been talking about CPU cores, right? So that's solves per clock tick. Where did GPUs fit into this licensing scheme?
Ooh, that's a fun one. So GPUs, basically, they were purpose built to solve matrices. Right. And if you think of your screen, it's just a gigantic matrix of pixels. Mm-hmm. So when it's trying to render an image, it's doing really, really fast, very, very specific kind of math. Of course, tinkerers being tinkerers, they said, hey, we could solve math problems on this. And they started writing code that can run on GPUs. And so Ansys got on that bandwagon, and now a lot, if not all, of these solvers have a GPU capability. Now, GPUs, if you go look at them and you look at how many cores, you're talking 3,000 cores, 2,000 cores, and it would be, a little bit short of insanity to charge per core on a GPU. So what Ansys did is they license a GPU as a single CPU core, because you cannot utilize it fully for the solve. It's only for the highly parallel matrix kind of solving part of it. So if you're running on, 3 CPU cores and a single GPU, then you don't need an HPC license. But beyond that, you would start adding. The limitation there is you can't have more GPUs than CPUs.
Okay. Yeah, you have to put a core to each GPU, to manage it. Yeah. Cool.
Yep. I'll say there's one exception there with the now native Fluent GPU solver. Mm-hmm. It's not as simple. It's now based on the number of streaming multiprocessors, and maybe Ahmed knows what that means. but it's not just as simple as swapping a GPU as one CPU. So, okay. But the traditional Fluent solver that just uses GPU acceleration for part of the simulation, okay, that is that easy swap. One GPU is one CPU.
That's a really good point, because they are starting to write solvers that don't just use the GPU for a step or two in the matrix solve. They do the whole thing on the GPU, which I think is what the new Fluent GPU solver is doing. Yeah. Cool. So I definitely understand it better. I still feel like you need to write it as if you're one user and you're just doing HPC, it's easy. But if you are running one job at a time, but if you're running multiple jobs, you got multiple users, it gets a little complicated. And I think drawing pictures kind of helps with that. But the basic idea is you get 4, and then you add either individual licenses from a work group, or an individual license purchase, or a pack as a group of licenses to the solve, and so it's 4 plus whatever you add. So and GPUs count as a CPU in most cases. So seems straightforward, right? And just in case people don't know, how is this administered? Is it using the standard Flex LM licensing?
Yeah. So once you get a license file that contains HPC, there's a task that is added, either HPC pack or Ansys HPC. Okay. And there's nothing special beyond just adding the correct license file.
So if I want to use it, as long as I point to my license file, I have access to those. And somebody hasn't restricted it through fancy stuff, I have access to those, right?
Correct.
And then if I'm a user, how do I know how many licenses my company has for HPC?
Ooh, that's a good question. Yeah. So
I would
Ansys,
look at the license file, but most people don't have access to that. So
yeah, so majority of people don't have access to that. In the later versions of Ansys, being 21R2 forward, there's a new tool under the Start menu, under the Ansys folder, and it's called Ansys Licensing Settings or Ansys Client Licensing Settings.
okay.
And if you open that, there's a view status or view features in use.
Oh,
Yeah, and clicking that will basically get you a dump from the license server showing each line item, how many licenses are issued, and how many are in use.
so you can tell that the combustion guy has used up all 128 of your parallel cores licenses. Okay.
Yeah.
and so you have to beg to share some. Okay. That's good to know. That's really good to know. So what was the name of that tool again?
It's Ansys Licensing Settings or Ansys Client Licensing Settings, depending on the version.
And that brought up another question I had, which is this all works with remote solve and core, correct? As long as you get your licensing, or sorry, I said core, cloud, as long as your licensing is set up correctly.
Yes. So Ansys is pretty cool when it comes to this part of the licensing.
Mm-hmm.
As long as the software sees the license server, it will run. Okay. If it's, if you're in the cloud somewhere, hey, maybe in a few years on the moon, and you're solving from here, as long as it sees the license server and it has a decent response time, it will run.
That's a long VPN connection.
Yeah.
Cool. That's really, really good to know. Okay. I feel like I understand it a lot better. Does anybody have anything that we missed or that they want to add or clarify? Yes, go ahead, Ted.
A couple of things. So one is, questions we get asked a lot.
Yes.
What about virtual cores?
Okay.
And so that's one. We can have a team talk about that. And another one more recently is the performance versus efficiency cores.
Oh,
some of the newer Intel processors.
Not heard of that before. Let's do the virtual first, and then the other one second. Anybody want to tackle that?
All right, I guess
it's you.
Go ahead. Go ahead.
All right. Well, I guess the historic position of Ansys has been turn off virtual cores. Okay. So normally the Ansys solvers don't utilize virtual cores. I think there are some exceptions, but in general, don't consider virtual cores as cores that you're going to use to solve Ansys on.
Okay. And is that something you change in the OS, or do you do it from an Ansys level?
That is a BIOS setting.
It is a BIOS setting. Okay.
Yeah.
So if you've got a box that you're running a lot of parallel on, you should just go ahead and turn off those virtual cores.
Virtual cores are basically oversubscribing instructions to the number of cores. So, for example, anybody who remembers analog phones, like a neighborhood would have 60 lines assigned to it, but there would be 200 homes that are using those lines, and the phone company is betting that you're not going to have more than 60 people at a time. And CPUs are doing the same thing. So you have 12 cores, and they're making 24 cores available to the OS, and they're betting that only less than 12 are going to try to solve at the same time. So that's the concept of virtual cores.
Cool.
And when you're solving your Ansys model, chances are the physical cores are all being utilized 100% or close to that.
Because you're hammering them. You're not browsing the web. You're hammering it. So that's good. Okay. So the second.
So then
one,
we get
Ted,
to the performance versus efficiency cores, and this was a question that we had come up within the last month from a customer here at PADT, and I believe. We found some older information, but I believe the latest version of the Ansys hardware document has some information in there. Does anybody remember what that was?
I happen to have it open, so I could
Cool.
speak up.
Great.
They say for these new hybrid architectures that have performance cores and efficiency cores, that you should set process pinning or affinity to run on P cores only. So the performance cores only for best performance.
Okay. And that's an Ansys setting or a BIOS setting again?
I'm not clear. I think that might be a BIOS setting, but I'm actually not sure myself
It
because I don't
sounds
have one
like
of these
it.
machines.
Sounds like it.
Yeah.
So there is a setting in the BIOS to basically block access to the efficiency cores, but of course we couldn't leave this at the surface. We opened a service request with Ansys and dug into it, and the latest response that I got from the development was to not set affinity, but not consume any more cores than performance. And this basically, the Intel, the way it does it, will use performance first and then offload to the efficiency cores.
So if I've got 4 performance and 4 efficiency, only ask for 4 cores, because if I ask for 8, it will try to use efficiency cores, which will slow me down.
Exactly.
That's good to know.
Yeah,
so it's an evolving
I found that out recently.
Okay, evolving topic. Definitely check that out. I don't know that we have any of those new boxes that have this new efficiency core, but it's definitely something to pay attention to. If you do get a machine and it's behaving slowly, that could be one of the reasons why. You don't want to pay for those HPC packs and then run it on a core that's made for basically doing background operations, right?
There's a couple of other considerations that come up when we're dealing with HPC sizing and use. Number one, the first and foremost is the CPU is but one piece of the equation.
Right.
So if you have slow RAM or a slow network connection or a slow hard drive, then expect a slow outcome. Your computer is as fast as your slowest component.
Right.
So that's the first thing. The second thing to consider is, what is the pattern of use that you have at your company? For example, if you go to the big aerospace or the big automotive companies, they have, we have 25,000 cores to play with, or things like that. So they have schedulers and resource managers and a way to manage all of this demand. But if you're, 3 guys that just moved out of the garage into your first office, it's important to consider what's the usage pattern. Is everybody going to be hammering HPC all the time? Is it on demand? Is it one guy who hides in the dark room who runs all the HPC? So talk to your Ansys channel partner and explain as much as possible, and that way we could probably do a cost-effective method. I don't want to say the E word, but
I was going to ask. Go ahead.
Another option that you can get Ansys licensing as is elastic licensing, which is you basically pay as you go. If you recall, like 10 years ago, you get 3,000 minutes from Sprint and you use them. End of the month comes, you lose them and you get another 3,000. In this case, it's end of the year. So you buy credits on the Ansys flexible licensing platform, and you use them as you need them. And the subscription lasts for a year, and you could consume them. If you run out, you can add on top of those. And then what that provides is the flexibility. So you could use all of your credits for HPC. You could use it for solvers. You could use it for tools that you're exploring. Am I ever going to use this? You can launch it and use it and be like, nope, not my kind of. Not useful for my business, and shut it down, and it won't cost you a yearly license.
Right. Or a great use case is, I've got this one job that I want to run on 64 cores, and I'm never going to need that again. So instead of buying a license or leasing a license for 64, you can buy the elastic, assign those as HPC, and use it that way. Good. Yeah. So, and I highly recommend, if you're going to use Elastic, talk to your salesperson and the tech support provider and make sure you understand it, so you use it efficiently.
Yep.
Cool.
So there's another thing that I'd like to bring up. So we get asked questions on, can you help me scope out a good system?
Okay.
And so there is an Ansys hardware document. It's available on the Ansys customer portal. I think if you log in and search on hardware document, you'll find it. So that does get updated periodically, and it has recently been revamped within the last couple of months. So that is a great source of information that for people that are looking to purchase a system. It could be a laptop, it could be a workstation, it could be something larger. So look for that. And the other thing I'd like to mention is Ansys does have a free benchmark program right now. So it allows you to upload a model to Ansys, and it will get solved on, I think what they described as a small HPC system, but that could be a way to help you determine what kind of benefit you might achieve from using HPC, and might help you, get steered in the right direction on what type of hardware you might look into getting for yourself. If you're looking for that, if you just go to the Ansys website, ansys.com, and type in the search field free benchmark program, you should be able to find it.
That is very good to know.
There are some, terms of use you have to agree to, but it's there and it is available.
Yeah, you obviously can't trick them into running your production job, but I think it's really important that everybody knows that's you're gonna spend money on licenses and hardware. So doing a benchmark beforehand is really nice. For your kind of problem, does a GPU help or hurt, or do you need two? Do you need one? These are great things to be able to answer.
And there are standard benchmark data that is published on the Ansys website as well.
Good. Okay. That is good to know. Wow, this is great. Anything else? Okay. I think we got it understood. And for the HPC stuff, if it is still not clear, highly recommend that you reach out to whoever you get your Ansys from, your Ansys support from, and they would love to help you understand it. And I think that's it. I really appreciate your time. I'm going to try and hold this in my head till we talk about it again. So somebody asked me, I don't have to say, go talk to Ahmed.
Yeah, a lot of development going on at Ansys Inc. on HPC GPU solving. We touched on that. Fluent now has a GPU solver. At 2023 R1, not all the Fluent capability is in there, but there is a lot, and it solves very quickly.
Yeah, we really didn't talk about it, but it's in some cases linear, right? If you add 32 cores, it runs 32 times faster. GPUs can give you even bigger increases. So it's really, really cool stuff. So check it out. Check out our blog on the blog articles on it, and check out the Ansys blog articles on it. And if you're sitting around drinking 5 cups of coffee to get a solve, you should be looking at HPC beyond the 4 that come with your core licenses. Cool. Well, thanks, guys. We'll talk soon. Appreciate it.
Sounds good.
Thanks, everyone.
Bye-bye.
Hopefully that sheds some light on things. My big takeaway is that you should be able to find the right solution for your needs in the long run and for those short-term peaks. As always, if you have any further questions, please do reach out to us at podcast@pdtinc.com or reach out to whoever you get your Ansys support from. Since this is a short episode, I'll keep the commercial short as well. The whole time we were talking about Ansys HPC, I was also thinking about Ansys Cloud. As you know, PADT has a very active consulting team, and although we run most of our jobs on our in-house hardware, sometimes we need a faster answer, or we have a problem that is just too big to fit on the machines we have. That is when we switch over to Ansys Cloud. It's easy, it's fast, and it's cost-effective. When we tell our customers, I can get this project done in a few days if you want to pay to run it on Ansys Cloud, they often, because they're engineers, they get scared and they back away and they say, that's going to cost too much. Then we tell them how much it is actually going to cost, and then their response is almost always, why didn't we start running there? So check out Cloud. If you are a PADT customer, the same people who just talked to you about HPC will walk you through all the options we have on Ansys Cloud and then help you get started once you get going. If you don't work with PADT, reach out to whoever your salesperson is, and I'm sure they'll be able to help you as well. It really is a great way to increase your capacity and speed up your projects. So if you're putting off trying it out, give it a try. Anyway, we're not going to go through a lot of news today. Again, this is a short episode. Just wanted to mention the Ansys stock ANSS is down a bit to 293 when it closed yesterday, which was May 10th. We'll look at their Q1 press release on the finances. They did that a few weeks ago in the next episode, and then get in depth into the stock and that kind of financial stuff when we go through that information. I'm going to skip the rest of the news, no blog articles, and we'll catch up on that on the full episode that we come up to. We do have a couple of events that I want to mention. PADT will be at Hill Air Force Base Tech Expo on May 24th. It's a great event. The Air Force and their suppliers are doing some really cool things out there for both maintenance of older aircraft and then newer aircraft. And there's just a lot of technology going on there at Hill Air Force Base north of Salt Lake City. So if you're going to be there, definitely stop by and say hi to PADT. And if you're just a listener in Utah, reach out and we'll have a team there and maybe they'll stop by and say hi. On that same day, May 24th, our next webinar will be on structural updates for 2023 R1, and we're going to focus on optimization and explicit simulations in structures. So don't miss that. One of our favorite topics is explicit simulation, and another one is optimization, so that's going to be a good one. And you can register at brighttalk.com as you can for anything that PADT does webinar-wise. Just go to brighttalk.com, search for PADT, and you can see this webinar and recordings of all of our past webinar. It's all free, it's all easy to access, and it's all very informative. So that's what I got for today. I want to thank you. Don't forget to subscribe to our newsletter. A new version's coming out in a few days. www.padtinc.com/opt-in. Spread the word about the podcast. Please subscribe if you have not already. And as always, don't hesitate to reach out. Thank you for joining us for this abbreviated version of the All Things Ansys podcast, episode 118. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.pdtinc.com/blog, and please share your thoughts and questions through an email to podcast@pdtinc.com. And as you've seen, if you ask for something, you'll probably get it. We'll see you next time.